All right, let's dive right into one of the most mind-bending questions you can possibly ask, the simulation hypothesis. This is the wild idea that our entire reality, everything you see, everything you touch, you, me, it might all be just an incredibly advanced computer program.
You know that feeling, right? That little flicker of doubt when you're staring up at the stars, or maybe a wave of déjà vu that's so strong it feels scripted. Now, I know it sounds like something straight out of science fiction, but some of the world's brightest minds are actually taking this possibility very, very seriously.
And look, this is no longer just some late-night philosophical debate. The arguments for it are now being built on the back of technology that we ourselves are creating. Virtual worlds that are becoming so convincing, they're forcing us to look in the mirror and question the nature of our own reality.
To even begin to wrap our heads around how our universe could be a simulation, it really helps to start with the simulations we build for fun. I'm talking about God games. For decades, we've been obsessed with playing Creator, guiding a whole civilization right from the ground up.
This whole process follows a really simple but powerful loop, and you can see it perfectly in a game like The Universum. You kick things off with just two little cave people. The game calls them nuggets. Then you give them knowledge, like, hey, here's how you make a tool. You use your godlike powers to drop in some wood and stone, and then you just watch. You watch as they build an entire society from scratch, all under your invisible guidance.
Okay, so that's a simulation on a pretty small scale. But what happens when that ambition just explodes? What if the goal isn't to build a little village, but to create a complete, one-to-one digital copy of our entire world?
And that brings us to the absolutely massive undertaking behind something like Microsoft Flight Simulator. The goal here? Recreate all 197 million square miles of planet Earth so it feels totally real from 30,000 feet up. I mean, the technical challenge is just staggering.
So if you're going to build a digital Earth, you've really got two main ways to go about it. First, there's 3D scanning, which is what you see in parts of Google Earth. The detail is incredible because it's a direct copy of reality, but you just can't scan the whole planet. The second way, and this is what Flight Simulator does, is AI-generated reality. The AI looks at 2D maps and just builds the world, automatically plopping down buildings and trees based on a set of rules. This gets you the entire globe, but the trade-off is a huge loss in fine detail.
And, well, when you drop down from that bird's eye view and start looking closely at this AI-generated world, that's when the illusion of reality really starts to fall apart. You start to notice the glitches. Cars just driving right over stadiums. Famous, beautiful cathedrals that are now just flat pictures on the ground. Bridges that aren't bridges at all, just road textures painted over the water. You might even find your own house has been replaced by some generic apartment block. These are the shortcuts, the little mistakes that show you the digital seams holding this whole world together.
See, those mistakes happen because the simulation is only copying what the world looks like. And that brings us to the next great leap. What if a simulation could learn not just the appearance of a world, but its fundamental physical rules?
And this is where we are right now, on the cutting edge of a new generation of AI. We are literally teaching machines not just to paint a picture of a world, but to dream one up that follows consistent physical laws.
The key idea here is called world modeling. Instead of just faking it with pretty video clips, that's the visual mimicry, the goal is to build a world that actually understands cause and effect. The AI learns the transition dynamics. In simple terms, it learns the rules of physics so that things move and interact in a way that just makes sense over time. And believe it or not, we're already doing this. Projects like Lingbot World show us the recipe. It's a three-step process. First, you feed the AI a massive diet of data, real videos, game footage, you name it. Then you train it step by step, starting with just generating video and then slowly teaching it about interactivity and memory. And finally, you shrink the whole model down so it can run in real time, letting a person actually jump in and interact with this AI-dreamed world.
The results are just stunning. You start to see what's called emergent behaviors, things the AI was never explicitly programmed to do. Landmarks stay in the same place even after you look away. A car that drives off-screen continues on a logical path, so when you look back, it's right where it should be. The AI has learned object permanence. It is maintaining a persistent, logical world all on its own.
So let's just pause for a second and think about this. In just a few decades, we've gone from blocky, pixelated games to AIs that can generate persistent, physically consistent realities. If our technology is moving this fast, it forces us to ask the ultimate question. What if a civilization far, far more advanced than ours already perfected this a long time ago?
And that leads us to our final and most profound step. Let's take that mind-bending zoom out
and actually look at the clues that suggest our universe, our reality, is the simulation.
The first argument is really just a numbers game. It's pure statistics. The idea is, if any civilization, anywhere in the history of the universe, gets to a point where they can run lots of ancestor simulations, simulations of their past, then the number of simulated people, like us, would eventually be way, way bigger than the number of beings in the one base reality. Statistically, it becomes almost a sure thing that we're one of the simulated ones, not the original biological few.
But the clues get weirder. And they're hiding in the bizarre world of quantum mechanics. First off, at the tiniest scales, reality seems to have a resolution limit, what's called the Planck scale. Could that just be the universe's version of a pixel grid? Then there's quantum entanglement, spooky action at a distance, where two particles can affect each other instantly, even if they're light years apart. It seems impossible in our world, but for a computer program, it's easy. You're just updating two related variables at the same time. And maybe the weirdest clue of all, reality only seems to pop into a definite state when we actually look at it. This sounds a lot like a common programming trick called lazy evaluation. Why waste the computing power to render a tree if no one's in the forest to see it?
And then there's the giant mystery of math itself. For centuries, the smartest people on the planet have been baffled by why our physical universe can be described so perfectly by these abstract mathematical equations. Well, in the simulation hypothesis, the mystery just disappears. Of course the universe is made of math, because it's a program. The laws of physics are just lines of code.
And this implies something else, doesn't it? If we're in a simulation, it might not just be running on its own. It might actually have a purpose. Are we some cosmic experiment, an ancestor simulation? Or maybe, just maybe, the beings running our program are watching, studying, or even tweaking the variables in real time. Which leaves us with one final, massive thought. Every simulation we create for a reason. We simulate weather to predict storms. We simulate economies to test ideas. So, if our universe is a simulation designed to create conscious beings like us, it raises the most important question of all. What is our purpose? What's the point of the program? What story are our lives all together telling our creators? That just might be the most important question we can ever ask.